So hello guys, welcome back to channel. So today we are going to discuss about the important topic in our ADSA, so which is heap, binomial heap. So let's do a quick uh, topic exploration. So this video consisting of three parts. First one is creating a heap, binomial heap. So second one is deleting a particular node, and third one is extraction of a main element. So we will do it part by part. So let's discuss first topic, which is creation of heap, binomial heap. So we have taken these many elements to create a binomial heap. So let's start by inserting these elements. First we have 15, so we need to make a node of 15. So inserting a tree which is empty, so we can directly insert. We have 15 and we created a node and inserted it. Second one, so 20 we have, so we need to create a 20th node and insert it and link it. So here we need to check the node if they are having a same order or not. So we need to calculate order. So here this one is having a order of 0 and this tree is having a order of 0. So here the two trees are having a same order, so we need to club them and make them a single tree. So here we need to check which node is having a minimum value. So in this case 15 is having a minimum, so 15 is a minimum, so we need to make the 20th node to its child. So we will do it like this. So we will create a node and insert a 20 here, because the heap, binomial heap, the follows min heap property, which is having a parent node is must be having a minimum value than its child node. Okay, so next 40 we need to create a node and insert it. So after that we need to calculate a order. So here we having the order, so this will update. So here we are having a different order, so we cannot merge them and make a single tree. So again we need to insert a 16. Okay, so inserting 16 is easy. So we need to create a node and we need to merge them, and we need to check, we need to calculate the orders. Okay, again we need to check, is there any tree having a same order. So here these both are having a same order, b not, so we need to merge them. How can I merge? We need to check the node which are having a smaller value. So here in this case 16 is having a small value, so we need to make this 40 a child for this 16th node. So here we can create a node and make this to its child. So this node will be erased, so this tree will be merged together. So again we need to check the order of it. So here we are having a two trees which are same in order. So this is also b1, this is also b1. So again we need to check the parent node which is having a smaller value. So in this case 15 is a smaller value, so we need to make this to its child. So how can we do it? We need to create a node and insert this 16. So 16 is inserted. So 216 which is the child node, the 40 is the child node. So the entire tree is attached to this tree, so this one will go erased. So again we need to check the we need to calculate the order of it. So here this tree is having a order of 2, so b2. So 16 is inserted now, and we need to insert a 70. So 70 we can insert by creating a node and making it to link. So we need to check the order of it. So we need to check, is there any same order or not. So in this case we are not having a same order, so we can move on. So after that we need to insert a 80. So here I will create a node and insert. Okay, so after that, after insertion, we need to calculate the order. So here these two are having a same order, so the next step is merging of them. So to merge, we need to check the parent node which is having a minimum. So in this case 70 is a minimum, so we need to make this 80 to its child. So what we can do is we need to create a node and insert a 80 here. So this 80 becomes its child now, so we can erase this one. Okay, so again we need to calculate the order now. So this one is B1 tree, this one is B2 tree. So here there is no confliction of same order, so we can move on. So again we need to insert a 90. So we need to create a node and insert a 90 and make them link to the binomial heap. So now we need to calculate the order of it. So the 90 node is having a order 0. So this is order 0, this is order 1, this is order 2. So there is no confliction of order. So this is a correct binomial heap. We need to move on. So again I need to insert a 5. So I need to create a node of 5 and make them link. After making link, we need to calculate the order of it. Now we need to check same order, is there any existing or not. So in this case we have B0 B0, two trees are having the same. So again we need to check the minimum node which is having a minimum value. So in this case 50 is having a minimum value, so we need to make this 90 to its child. Okay, so we need to create a node and insert a 90. Okay, we can delete this node now. So after deletion we need to merge these all. So after that we need to calculate the order. For this tree we are having a order 1. So again we need to check, is there any tree having a same order or not. So in this case we are having two trees having the same order, which is B1. So this is also B1, this is also B1. Again we need to check, is there any like in the parent node which one is having a minimum value. In this case fifth one is having a minimum value, so we need to make this entire tree to its child. Okay, so we can create a node 70 and the 80. The entire tree is become a child tree for the binomial heap of this one. So after that we need to delete this one and we need to merge this one. So after that we need to calculate the order of it. So this one is having a order 2. Again we need to check, is there any confliction of inner order. So this is also order B2, this is also order B2, so we need to merge them. So in this case the fifth the node first tree is having a minimum value, so we need to make this entire tree to its child. Okay, so we need to create a node and we need to insert the entire tree to its. Okay, the 15 and 20 and this one is 16 and the last one is 40. So this became a child node to this tree. So after that we need to erase this one. Okay, and this complete the insertion of 5 value. After that we need to move on. There is no other tree to check the order or not, so this value updates to B3, order of 3. This tree is having a order 3. Okay, so we need to insert a node 2. So we need to create a node, insert a value and make it to attach to this tree. Okay, in this we need to calculate the order. So this is the entire last output of binary heap. Okay, so in this we have a tree having a order 0 and in this order is 3. So there is no confliction and there is no insertion of another value in this. So this is the entire output we get after creation of these all values. Okay, so in this case we completed the insertion and creation of binomial heap. So moving to next topic, which is deletion of the particular value. Okay, so in this case we have taken 80 as a value to be deleted. So we need to track where the 80 is. In this we having here we are having a 80 value in this node. So we need to replace this with minus infinity. Delete this and we will insert a infinity here. So the minus infinity is lesser than all the values which are in the binomial heap. So what we can do is we need to recreate the binomial heap now. So what we can do is we need to transfer this to here and this to here. Okay, the output is, so here we will having a 70. Okay, so we have shifted this infinite minus infinity to one step, and after that we need to shift, we need to check, first we need to check the minus infinity is lesser than 70, we shifted it. Okay, so again we need to check minus infinity with the 5. Here in this case minus infinity is lesser than all the values, so we are simply shifting it. So we need to shift to this root and this value will be here. Okay, here sorry, so I will create a 2 node here, and the node having a minus infinity here is 40. We have reassigned, recreated an entire tree. Okay, here we are having a tree which is the root node is minus infinity. Now we need to extract that node. Okay, so we need to extract that node, and after extraction this node which is having a value 80 will be deleted from the heap. Okay, after deletion of minus infinity we will get the child nodes separately. So we need to make those child nodes to the root nodes. Okay, after making them root node we need to merge them to the binomial heap. Okay, so after deletion of this minus infinity we got these three childs, so we merge them to root. Okay, so after merging we need to calculate the order of its. So in this case we calculated the order, this one is b naught, b2, b1, b naught. So in this case this is not a complete binomial heap, so we need to merge these two trees which are having the same order. So in this case 90 is less than 2, so we need to make a this node as a child to this node. So we will make a node and insert a 90. After that we need to delete this one. So after that we need to update the orders. So in this case this will become 1, this is 2, this is 1. After inserting 90, so these two are having a same orders. So again we need to merge them. So we will merge here. So in this case we need to check a root node, 5 is less than 2, so we need to make this entire tree to its child. So we will create this 2 and 90 is already there, so 90. So we will make this entire tree to this node, like a child node. So 5 and this one is 70. So this is over. So its order is b2 now. Okay, so this will go off and this one will also erased. So in this tree we have the two binomial trees. So this is heap. So here we are having a two trees having a same order. So this one is b2, this one is b2. So again we need to merge them. So we need to check the minimum value. In this case 2 is a minimum value, so we need to make this entire tree to its child. Okay, so we will make this entire tree. So 15 and 20, and it's to 16. This one is 40. So after merging, so after deletion of 80, we will get a binomial heap output as this one. So this is binomial heap having a order B3. Okay. So we deleted 80, the value 80 from the binomial heap. Okay. After deletion of 80, we got this tree. Okay. So let's move on to the next topic, the next operation, which is extraction of minimum value. Okay. So in this case, the highest root node is having a minimum value as the property of binomial heap. So we need to delete this one. So after deletion, we will get these trees of, so we need to make them a root node. So we will connect this to this to this. Okay. After this, we need to make sure that is this completely binomial heap or not. So do that, we need to calculate the order of its. So this one is B2, this one is B1, this one is B0. So in this case, there is no confliction of orders. Okay. This is the complete binomial heap. Okay. So we have done three major operation on binomial heap. So by this we are completing this video. I have created a simulation in a web. You can do all the operations which are possible on binomial heap. So I will include that link in the description. Do check and do subscribe, like, comment. Okay, thanks for watching guys.